So hello students, today I am going to explain boron trifluoride. This is the compound of boron. It's given in the page number 38 in volume 1. So how do you prepare boron trifluoride in laboratory? See, in laboratory, when benzene disonium tetrafluoroborate, the formula is pH. pH, it represents phenyl group C6H5 and N2 boron, and there are 4 fluorine atoms. Benzene disonium tetrafluoroborate, on heating it undergoes thermal decomposition. It forms boron trifluoride and phenyl fluoride and nitrogen. Phenyl fluoride in your textbook it's given as PHF. Even you can write C6H5F. And other two methods from boron trioxide. Boron trioxide, when it is treated with calcium fluoride in the presence of sulfuric acid, it gives boron BH3 and also BF3 and calcium sulfate and water BF3. This is BF3. And boron trioxide, when it is treated with carbon and fluorine, it gives carbon monoxide and boron trifluoride. So, totally there are 3 methods of preparation of boron trifluoride are given. One is laboratory preparation, that is very important method. Otherwise, even the question may be asked, how do you convert benzene disonium tetrafluoroborate into boron trifluoride? And then, next let us see chemical properties. In the chemical properties, boron trifluoride acts as Lewis acid. What is Lewis acid? Lewis acid is nothing but that is the electron deficient reagent. So therefore it can accept the electrons from the electron donor atoms. Electron deficient, because boron trifluoride, boron is surrounded by only 6 electrons. It is not completed its octet form. Therefore, it is readily to gain 2 more electrons to complete the octet form. So, let us see some example for that. Boron trifluoride, when it is treated with ammonia. In ammonia, nitrogen, it has lone pair of electrons. So, it donates the lone pair of electrons to boron and it forms the coordination bond. You see here the coordination bond. Last year you studied how do you represent the coordination bond. The coordination bond is represented by a arrow mark. The head portion of the arrow mark is towards the acceptor. Okay, so therefore boron trifluoride and NH3 is there. Similarly, in water, oxygen, it carries 2 lone pair of electrons. So when boron trifluoride, so it is treated with water, oxygen from water, it donates 1 lone pair of electrons to boron and it forms a coordination bond, and it's given here. Boron trifluoride, coordination bond and OH2. Similar, next, so for this 2 mark, this is the 2 mark question. Write the action, otherwise explain the behavior of Lewis acid of boron trifluoride, otherwise how it reacts with ammonia and water. Hydrolysis reaction, you see, boron trifluoride, when it is treated with water, it gives boric acid and hydrogen fluoride. Boric acid and hydrogen fluoride. Boric acid, again it converts into fluoroboric acid. Fluoroboric acid, you see, the formula is HbF4. Whereas in your textbook it is given in the ionic form, H plus and BF4 minus. HbF4 is the formula for fluoroboric acid. It's given in the ionic form, H plus and BF4 minus, and also it gives what? Water. Okay, so here whatever the fluoroboric acid will be formed, that will be act as a catalyst in organic chemistry. And next, so these are the about the boron trifluoride preparation and properties. And next, aluminium chloride. Aluminium chloride, here you see aluminium also, it belongs to 13th group and its compound is aluminium chloride. So there are 2 methods of preparation are given. Aluminium, when it is treated with hydrochloric acid, it gives aluminium chloride and hydrogen. Otherwise, even it is also prepared from aluminium hydroxide. Aluminium hydroxide, when it is treated with hydrochloric acid, it gives aluminium chloride and water. And another one important method is there, that is the naming process, MAC-free process. In the MAC-free process also we can prepare the aluminium chloride. How can you prepare the aluminium chloride? By MAC-free process. Aluminium oxide or alumina ore. So when it is treated with coke and chlorine, so on heating it changes into aluminium chloride and carbon dioxide. Here the coke, actually it is a reducing reaction. So aluminium oxide, it is reduced into aluminium, then it combined with the chlorine to form aluminium chloride. Next one, industrial method. The industrial preparation of aluminium chloride, that is there is a direct combination of aluminium with chlorine at very high temperature of 1000 Kelvin. It gives aluminium chloride. Okay. And what are the properties of aluminium chloride? Aluminium chloride, anhydrous aluminium chloride, actually that is hygroscopic in nature. That is in powdered form, colorless and powdered in nature. And aluminium chloride, when it dissolves in water, it is acidic nature. Why it is acidic in nature in its solution form? Because aluminium chloride, when it is treated with water, it gives aluminium hydroxide and releases what? An acid, hydrochloric acid. Therefore it is acidic in nature. That is very, very important one word. Next you see aluminium chloride, it reacts with an alkali. So that means even the strong alkali as well as the weak alkali. First let us see the reaction between aluminium chloride and an weak alkali. Weak alkali, the example is ammonia hydroxide, and here this is the double decomposition reaction, otherwise replacement reaction. From aluminium chloride, the chlorine will be replaced by OH of ammonium hydroxide. Aluminium chloride, the chlorine is replaced by OH of ammonium hydroxide, and it gives aluminium hydroxide and ammonium chloride. Similarly, even aluminium chloride, when it is treated with a strong alkali like sodium hydroxide, it gives sodium aluminate. What's the formula? NaAlO2, and water as well as what it gives? It gives sodium chloride. Okay, so this is the difference between how aluminium chloride reacts with a weak alkali and strong alkali. Okay, then next one important question, aluminium chloride, it reacts with 6 moles of ammonia and it forms the AlCl3 6NH3. AlCl3, that is the Lewis acid, because it is ready to gain electrons from the electron donor atom of nitrogen from ammonia. Okay, so this is, it gives an addition compound. It gives what? Aluminium chloride, when it is treated with ammonia, it gives the addition compound in which aluminium chloride will be act as what? Lewis acid. What is Lewis acid? That is ready to accept the electrons from the electron rich species. Aluminium chloride it is used, the anhydrous form of aluminium chloride, that is used in the Friedel-Crafts reaction in organic chemistry. Last year you studied about the Friedel-Crafts reaction. Even aluminium chloride, that is used in the manufacturing of petrol by cracking method. Okay. Then next one, alums. Alums, you see, alums are double salt. It contains 2 salt. See, here one alum is given. K2SO4, Al2SO4 thrice, and 24 water of crystallization. This is called as potash alum. Potash alum, it contains potassium sulfate, aluminium sulfate, and 24 water of crystallization is present. Generally, even the alum can be represented by a common formula M2 dash single dash SO4, M2 double dash SO4 thrice, and 24 H2O. What is M2 single dash and M2 double dash? M2 single dash, it represents the monovalent ions like sodium ion, ammonium ion, and potassium ion. And M2 double dash, that represents the trivalent ions like aluminium and chromium ions. Okay, so with suppose in the instead of M dash, so even Na 2SO4 and M2SO4, Al2SO4 thrice is there, then that is called as what? Sodium alum. And if suppose in the instead of M2 dash, if NH4 ammonium sulfate is there, then that is called as what? More salt, otherwise ammonium alum. Okay, so alums are what? Double salt, which is made up of, otherwise which contains 2 salts. One is what? Monovalent salt, and another one is what? Trivalent salt. Preparation. It is prepared from Alunite or alum stone. What is the formula of alunite or alum stone? K2SO4, Al2SO4 thrice and 4AlOH thrice.